water, right? And then finally, when it becomes ice, as you can see here, they are beautifully structured in a crystalline form. So when they are crystalline in a structured form, but the gaps are so large in between. You see this? The gaps are so large in between. When you see these gaps are so large, the density of water becomes less, and that's why you start seeing ice floating on water, right? You see, this is how what a university postgraduate student will try to understand. You saw this? The student in the school just finds out that water floats on, ice floats in water. The college students understand it through the phase diagram. Then the postgraduate department looks at the molecular level and tries to understand how the atoms are. And then you have a research student who will start looking at the dipole moments of this one, the hydrogen bond in this one, the polar covalent bonds in this one, etc., etc. So see, look at this beautiful thing. The questions change as our knowledge grows. The same question why this student asked, why does ice float on water, is the same question of the college boy asking, why is this line bent? Okay, and then the same question of asking why in the postgraduate department asking why these molecules sit in different forms, why do they become crystalline, why do they roam around in a liquid, etc., etc. And then you have the final answer by telling, let's look at the details of that. So the questions of the same why has grown. So you also take some curious questions like this. Take a curious question, a simple question, and go on asking it. Every time you ask and find an answer, your knowledge will grow. So once your knowledge grows, you will become your next why question will be a much more interesting question, much more challenging question. So your next question, ultimately you become that great scientist. But now what we do, we ask this question, and somewhere we stop it. Because exam will come, then we have to learn everything by heart. So we will sit there, forget about the question, and start mugging up everything, and then go and write in the exam. And after the exam, we'll say, "Oh, Shapa, finished. My life is finished. I've done everything what I want. I've scored 90 marks out of it, but I have not understood why the water floats on water." That is our problem. If we follow it, if we go after it, there is no doubt that each of you can become a Nobel laureate. Okay. So now let me show this. This is a famous man, Sir Isaac Newton. You all know that. You all know his story. Of course, he was a big professor in the University of Cambridge. He was not an ordinary man sitting under the apple tree, which like the story says, but basically he was trying to understand why planets revolve around the sun. There were Kepler's laws of motion. There was so much knowledge before that, but nobody understood why this happens. And that is how, when he saw something falling down, he started asking this question, why did it fall down? Why only down? Why did not go up? Okay, why did it fall? At what speed did it fall? When it came down, what was the force on it? So these questions you all know ultimately led to Newton, amazing, great, one of the greatest scientists ever in the history of mankind, find out what are called as the laws of motion. Then the gravitation, he understood the concept of gravitation. He started the field called as optics, about studying light. Then he also invented calculus. Then he understood, to understand all the physical phenomena, you need mathematics. Okay. Initially, when we ask the questions, there are very simple questions. We can answer just like that. But once you go to more and complicated systems where we don't understand, okay, by our senses. See, we have 5 senses. We can see something to a certain resolution. We can feel something, we can smell something, we can taste something. We can do this within the limited resolution we have. But eventually, if you want to see something beyond our understanding, which we call it as scholastic learning, you want to understand beyond something which we can sense directly, then you need mathematics. That is why mathematics became a very important field. It was already there, you all know, because you could quantify everything. You could understand everything because the mathematics was so beautiful. When I was a student, I never understood that mathematics was so interesting. In fact, it was one of the worst topics. Worst topics. I never enjoyed doing mathematics. Only after my hair became gray, white hair, then I realized the importance of mathematics. Then I said, my God, mathematics is so beautiful. Unfortunately, neither my teachers told me that it is beautiful, nor did I understand that it was beautiful. Right? So I just thought, when I was a college student, I just thought that only girls were beautiful. Now, when the old age came, I realized that even mathematics is more beautiful. In fact, beauty is very interesting When I say a girl is beautiful, you see there also there is something called as a golden mean. It is also called as Fibonacci numbers. When you look at the Fibonacci sequences, you know that that is mathematics. So whenever we say beauty and the music, see, we hear some music, something it is beautiful, that is also mathematics. So the beauty of mathematics lies in describing nature. The nature is described beautifully through mathematics. So ultimately, even Newton realized to understand what is happening, how things are falling, how the planets are moving, I need to invent what is called as calculus, and that's what he did. Calculus was invented by Newton. Of course, his book, the famous book called as the Principia, is an amazing book with so much information. Still, many things have to be understood. Just like, absolutely beautiful kind of book. Okay, we know by just the simple laws of motion, now we can fire rockets, we can fire satellites, the cars, everything move based on just the simple laws of motion of Newton. So great contribution by Newton, because he asked this one small question: why does the apple fall to the ground? And then we all said, see, before Newton, his grandfather also the apple fell, his father also apple fell, but nobody asked this question. We also did not ask the question until we read in the college, in the school, that Newton found out that the apple falls down. Then we also read, oh, the kelag bidutalla. We never thought about it. So we see so many beautiful things, so many ideas, so many thoughts come into our mind, but we ignore them, right? If you don't ignore them, if you start asking these questions, okay, you will become Sir Isaac Newton. Okay, so now let us see the next man. Look at this wonderful man. We all know this famous man. Who is this? Again, hopefully, arguably, one of the greatest, most intelligent person in the world, that's what we say, is Einstein, Albert Einstein. You know, he was a terrible student, but he ultimately became a great scientist. Why is this? Because he said that he started asking the question why for everything. Amazing. What was the question he asked? There are a lot of work in the past, okay, by Poincaré, okay, Michelson-Morley experiment. So many beautiful things were done to understand the nature of light and the speed of light. It was already decided by Max Planck, okay, that there are photons. And then there were so many beautiful things which came, which made Einstein start thinking, how will the world look like? Okay, he started asking this question: what will the world look like if I sat on a ray of light? The question was very simple. He knew that the light travels at 3 lakhs kilometers per second. If I sit on that ray of light, how will the world look to me? That's what he tried. And that is one question which led him to decipher the theory of relativity. You know, the theory of relativity is an amazing contribution to this world. Not only we understand so many beautiful things, including the black holes, but also it works for something like GPS. The GPS works because of the accuracy which is calculated by the theory of relativity. So relativity was fantastic. And in that theory of relativity, Einstein said that the velocity of light is constant and time is not constant. Time can be changed, mass can be changed, everything can be changed, but velocity of light is constant. Right, friends? There is an opportunity. So if you can find a particle which moves faster than the velocity of light in vacuum, okay, you will become the next Albert Einstein. So start thinking about this question. Okay, there are a lot of questions. Even George Sudarshan, our own Indian scientist, came out with this beautiful theory of tachyons. But ultimately, of course, it did not prove that it had velocity faster than of light. But you can think of beautiful things. It may be possible one day that Einstein is proved wrong. Okay, but at this point of time, every experiment which has been done to disprove Einstein have turned out to be false, and Einstein has always been found to be correct. Now let's see. Because of this constant, you know that theory of relativity was invented. Of course, Einstein is famous for 3 important things. One is the theory of relativity, the other is the photoelectric effect, and the third is Brownian motion. But one of the greatest achievements is the theory of relativity. You know, theory of relativity cancelled the idea of concept of gravity of Newton. Gravity is now, he found out, it is nothing but a warp in the time and space. Okay. Again, I don't have time to explain to you, but you wonderful people start asking this question: why? What is the concept of gravity by Newton, etc., etc. Then you will find some amazing things. And Einstein's contribution was great in the formula when he found out the formula E is equal to mc square. By the way, you must be knowing the story that Einstein did not get the Nobel Prize for the theory of relativity. He got the Nobel Prize for the photoelectric effect. Because the theory of relativity, very interesting story. I mean, some of you may not have heard this. In fact, when he got the Nobel Prize for, when he discovered the theory of relativity, there was a lot of protest against him. They said this fellow is a plagiarist. Okay, he's copying from everybody. All sorts of data which was there. There was nothing new in Einstein's work. There was a big, big criticism. Very many years, people criticized him and said that this is not, this is not your work. This is not your original work. But ultimately, that people understood how original he was because he was able to put all these ideas together and he was able to understand what is happening. Can you hear me? Can you hear me?
Yes, sir. Yes.
Okay, I'm sorry because I got some signal here. So theory of relativity came, everything life changed out after that. So now you see, now let us look at Lord Rayleigh. Okay, Lord Rayleigh asked this question, one simple question: why is the sky blue? Right? Everybody, we all see the sky blue every day. We don't care. Blue is there, blue irli. But Rayleigh asked this question: why is the sky blue? Then he started understanding why is the sky blue? Because the sun gives out all the colors. It gives all the Vibgyor colors. All the colors come to the earth. But why is the sky blue? Then he understood from his thing that the blue light has a smaller wavelength. So it is of the it can scatter a lot from all the air molecules, the dust particles, the water molecules inside in the atmosphere. And that's why the blue light scatters while the others don't scatter. Because something like red light, which has got a long wavelength, can easily miss the particles in the atmosphere. And that is why their scattering coefficient is small, but the blue light has a large scattering coefficient. It is to the power of frequency to the power of 4. So that is why we see blue light scattering and a little bit of green light scattering. And that is why when we see from here, that light which scatters sideways is the one we see. And so it appears that the sky looks blue. When this was done, then our own Indian scientist, C.V. Raman, he said, oh, it's very interesting that light can scatter from the Rayleigh effect, which is called as the Rayleigh scatter. So he started thinking, but what will happen if it scatters from a molecule? Okay, because the molecules are not stationary, not like sitting like balls here. So what will happen if it hits a molecule? Because molecules are always moving, right? So what are called as rotational motion, the vibrational motion, and the angular motion. So you can see the linear motion, the rotational motions, and the translation motion. All these motions are there. So what happens? Raman started thinking. He was very sure something interesting will come out of it. And so this is how he did. You know that Raman has a wonderful, wonderful story. He's probably the most inspiring scientist ever for every Indian. I mean, he saw that it's like, for example, a water molecule here. You can see there are different kinds of modes: the stretching modes, the vibrating modes, all sorts of modes are there. So he said, if a light particle comes and hits this, this motion should affect the energy of light. Rayleigh had said that the particle will come, the photon will come, hit this particle and go away without losing energy. He said that it was an elastic scatter. But Raman said, if it is moving, my light will come, hit it, and because it is moving, it will change its energy. That's what he did. He found out that there's an inelastic scattering of light. So you see, if the molecule is moving towards the photon, and this photon is coming, light is coming, if it is moving towards this, it will lose energy. So it will reflect in one direction by losing some energy. But if it is moving in this direction and the photon goes like this, then it gains energy. So you will see that he showed that any light energy which hits the molecule which is vibrating will give you two peaks, two inelastic scatterings, which is one which is called as the Stokes and the other which is called as the anti-Stokes. And that's what it was. And that is called as the Raman effect. Very simple, right? He started thinking, if a light gets scattered from a molecule, because the molecule is vibrating, I should see some change. I should see some change in the energy of the molecule. This is all the question he went on asking again and again and again. And ultimately, you know that he found out what is called as the Raman effect. And it gave the first Nobel Prize in science and the only Nobel Prize in science for India, for work done in India. So it is amazing contribution. It was again with this question, the small question, what will happen to the photon when it hits a vibrating molecule, right? It's very simple. See, it can occur to our head also. But the question is, we did not apply our mind and also try to understand. See, I'm talking about the simplistic picture of the whole thing. But to actually understand it, there is a lot of mathematics in it. There's a lot of thought into this. There's a lot of process which takes place. Raman is a very inspiring man to all Indians, because when he was young, he was studying in a college in Madras. Okay, at that time, Chennai, at that time called as Madras, he was studying in a college. They did the single slit experiment. The teacher showed that he made a small slit in a cardboard and put some light, okay, and showed that there's an interference pattern on the side, and he calculated from the interference pattern the wavelength of light. This was an experiment we all do in our colleges. Okay, they were doing it when he was only 16 years old, 17 years old. Then Raman asked this simple question to the teacher: if I put the light straight, it'll happen like this. What if I put it at a glancing angle? The teacher said, no, you should not put it in a glancing. You should put it like this. Like all our teachers say. They will not allow us to try something new, right? So, but he did not leave that. After the teacher he went into the laboratory, tried an experiment on his own, and put it an obliquely incident light, and he saw a pattern which was very different. It gave a completely new story about the wavelength of light. And that he published the first paper, when he was just 17 years old, Raman. And his teachers also did not know anything about it. But he could do that because he went on asking this question, simple question. If the light falls straight, it can form an interference pattern. He knows it. Now, if I put it at an angle, what will happen? Right? These are the simple questions which led to the beautiful Raman, who made this, ultimately found out what is called as the Raman effect. And of course, there are so many other works of Raman related to musical instruments, related to crystals, etc., etc. But Raman work became much, much more famous later when lasers were invented. Because earlier there was no laser. In fact, Raman worked with this small instrument, a 130 rupees instrument. Okay, when he studied this effect. Because at that time there was no source. They had to study it in sunlight. Okay, every time it was done in sunlight. But now with the laser sources coming, Raman became a great effect. Now it is so beautiful. Now there is a new thing, what is called a surface enhanced Raman spectroscopy. And in this surface enhanced Raman spectroscopy, the Raman signals are enhanced much, much more using the plasmonic properties of nanoparticles. Don't worry about what it means. But if you can use metal nanoparticles on a substrate and do Raman spectroscopy, its signals become stronger. So now we can study, Raman has studied only for liquids, but now we can study Raman for solids. We can study for everything. In fact, one of the best ways of using for detection of molecules, analytes, is the SIRS method. So now a lot of experiments are going. People are also trying to see if they can detect coronavirus at a very early stage using surface enhanced Raman spectroscopy. So these are some beautiful things which can happen just because some simple why, how, and what questions were asked by Raman. Okay, now let's see this Bernoulli. Okay, you have all heard of Bernoulli. Bernoulli asked this question: how does birds fly in the air? Okay, how does birds? That birds, when they go in the air, like especially like eagle, okay, when it goes high up in the air, it just does not flap its wings also. It just holds its wings like this and then goes and flies in the air. So he started thinking about it. How does it happen? Then he found out what is called as the Bernoulli Principle. You look at this picture here. This shows the Bernoulli Principle. You all know this. That because of the shape of the wing of an airplane, okay, this is the wing of an airplane, shape of the wing. So this molecule moves slowly because it has to go this distance and this distance at the same time. But these air molecules have to travel a longer path in the same time. So that means they will move faster. When they move faster, the distance between them will increase. So the pressure above this wing will be less than the pressure below the wing. And so the wing will be lifted up. And that is how aeroplanes fly. So we have a motor which will push air into the wing, and the wing, there will be a pressure difference created between the wing, between the bottom of the wing and the top of the wing, and that is how airplanes fly. That's why we have huge airplanes. Like, see the picture on the right side, you can see these beautiful airplanes with 500, 600 people sitting in the airplane and flying in the air beautifully. Such a heavy body flying, just because this beautiful principle by Bernoulli, called as Bernoulli Principle. He did not plan to invent an aeroplane. He didn't want to understand. He did not want to make anything big, right? He was just curious. How does the birds fly? Okay, what happens? What happens to the wings? Can I make my wings? Leonardo da Vinci, everybody tried how to do this experiment. Ultimately, the Wright brothers were successful in making the first airplane, but beautiful things came about it because of the Bernoulli Principle. Now look at this. This is another person called as Archimedes. Archimedes told his king that he was a scientist, that I can make chemical reactions. Then the king said, then make me a lot of gold, produce a lot of gold, right? And then, of course, he said, look, this crown of mine, my goldsmith has given me this crown, and I know this fellow has cheated. He has put some copper into this. Okay, he has cheated. The gold has been cheated. Okay, it has been mixed with something else. So can you find out how much gold he has, how much copper he has put into gold? This question came. This became a real headache for Archimedes. He tried to think, how do I find out? At that time, there were no spectrometers, there were no chemical reaction, nothing was there at that time. So Archimedes went on thinking and thinking and thinking, why, how, what? It's the same questions about everything. He started working. And he was thinking so much that he's thinking all the time. So what we do, we think only when the exams come. Otherwise, we don't think. We think about something else. Okay, but only when the exams come, we think about science. So the idea is not like that. The real scientists are always thinking about these simple questions, why, how, and what. And that's what Archimedes did. So when he started thinking about it and he went to take a bath, okay, he went into the bathtub, the water came out, right? It's obvious when he went into the water came out. Then he started wondering, my God, why did the water come out? Because I displaced the water. So how much water did it come out? What does it tell about me? Does it tell about my mass, my volume, my weight? What does it tell about me? Then he went on. He jumped out of the tub and said, "Eureka, Eureka!" It's not any Reka, Reka. He didn't go after any girl, but he said, "I found it. I found it. I found a reason how to find." What did he do using that? He said that ultimately I can calculate the density of a material exactly by dipping it in water and seeing how much water is displaced. Then he could put pure gold and measure its density. Then he put this crown of the prince inside that and found its density was lesser. Then he understood how much copper could be put into that because he knew the density of copper as well as that of gold, and he could calculate how much copper was there. And this was gave to the idea of concept of buoyancy, the force which lifts in a liquid, right? And that buoyancy is now to make these beautiful, huge ships. Even a small pin will go down in water. But look at these beautiful ships, how they float in water. Thousands of people, cars, aeroplanes. Now there are aeroplanes which can come and land on these ships. These are done just because of using Archimedes' principle of buoyancy. So you just have to design the bottom of a ship in such a way that the buoyant forces is much stronger than the forces which drag it down. So look at this. Simple questions, right? Archimedes did not plan to make a ship. Yeah, Bernoulli did not plan to make an aeroplane. Okay, Einstein did not want to make a bomb. Okay, atom bomb. Newton did not want to make satellites. Nothing. They had no idea what they're doing. They were just curious. They just wanted to find out how things happen. And that is how they could find out beautiful things. Now look at this person. So now this person, Charles Darwin, right? You all know, you heard of Charles Darwin. He asked this question, why am I better than my father and my mother? Okay, I also used to tell my father, look, I am better than you. Okay, my father would not agree. Okay, he would say, no, I am better than you. I said, why? Why do you think you are better? He would ask me. Then I would say, because you are more closely related to the monkey than I am, according to Charles Darwin's theory, right? Our ancestors are monkeys. So my father is more closely related than I am. So I am better than a monkey. And that is why I said I am smarter than you. And this is what he tried to do. Charles Darwin applied this question and tried to see how we change, how we evolve, etc. Of course, he wrote this beautiful book called The Origin of the Species, when he explains what the theory of evolution is. Of course, theory of evolution at that time, he did not know what is mutation, but now we know what is mutation. Mutation, he used to think that it was use and disuse, but now we know that it is related to mutation. That's a different story. We have advanced the knowledge a lot. So ultimately, we know from this every species in the world, how they have come, how they have originated, what has happened, etc. You know that, even in a human embryo, okay, you know that by looking at the way the embryo goes, it shows all the stages of evolution inside the embryo, even now. So we start from amoeba and end up as a human embryo, while you can see that in every stages of the embryo. It's a beautiful, there's a WhatsApp video, a YouTube video there. Please look for it. Every stages of the embryo, you can see that. And which also shows you the theory of evolution and how we have remained and how we have changed, etc. Now you see, there's another question. Now the next question is, why do we look like our parents? Right? I look like my father, somebody looks like my mother, etc. A little bit like my father, a little bit like my mother, my grandfather, something of that sort. There's a problem if you don't look like your parents, right? There's this huge problem. Okay, especially if you start looking like your neighbor's father. Okay, so then there is a problem. So this is a question which was asked by Mendel. Okay, Gregor Mendel asked this question. Okay, what is heredity? So at that time, of course, they did not know about DNA. They did not know anything about the structure. They did not know about all these beautiful things which we have found out now. But still, the observations, asking this question, why, what, how, again and again and again, make Gregor Mendel ultimately achieve the law of heredity, which is called as the book. In this book, as you can see, is Mendel's Principle of Heredity. So what he did was he actually studied pea pods, peas. He studied because see, he could not wait for human beings. His life will be finished before he looks at the hereditary changes in human beings. So he chose tea pods which grow every few months. Every few months you can get a new generation of pea pods. So he went on trying many things, went on measuring a lot of data. He collected millions and millions of data, traveled all over the world, looking at all the pea pods, looking at the shapes, the size, the color, the taste, all particular data. Now what is called as big data. Okay, he collected millions and millions of data, tried to analyze it, and understood how heredity takes place. Of course, again, there are a lot of advancement in this field after that, but it is there. And this heredity also now tells us, okay, the origin of people. We know where life started. We know how people migrated, how they moved, when they moved, etc., can be understood beautifully by this, by Mendel's theory of, of heredity. Okay, so these are some beautiful things again. Mendel was able to achieve because he went on asking this simple question that why do we look like our parents? Why do how are the features carried from one generation to the other? Right? This question and going after this question. So that's what, my friends. The idea is all these questions come in our head also. Okay, but ultimately the person who follows that question which comes into the head for the next 20, 30 years is the person who is going to become a scientist. So if you take any question which comes in your mind, follow it at different levels, go on enhancing the quality of your knowledge about that, and ultimately, you will go to a stage when people have not understood anything, and you are the first one to give some new knowledge. And that is what a scientist is, right? He has understood this question so beautifully well. Now the question came, you look at this, I want to compare here. When we were students, we saw this, there's a nucleus, then the electrons revolving around in an atom. Here there is a sun, and then again there are planets revolving around. Both of them look the same. But we now know that they are not the same. Okay, they are different because this goes, you can put this planetary motion in simple classical mechanics or what is called as the Newton's laws. But you can't do this with an atom. If it was true, because the electron is a negative charge, the nucleus is a positive charge. If it keeps rotating for some reason, ultimately the positive and negative charge will attract each other. Even the gravitational pull will attract each other, and ultimately the electron should go and collapse into the nucleus. This was a big question. So Niels Bohr was called as the father of quantum mechanics, tried to understand this question. So he said that ultimately he found out that electrons cannot be seen as balls. They have to be seen as waves. If we see the electrons are waves, then we can understand why the electron will not collapse, why it travels in fixed orbits around the nucleus. And this was beautiful, right? This beautiful concept, okay, led to the new field called as quantum mechanics. You all know that Einstein did not like quantum mechanics because quantum mechanics depends a lot on probability. Probability means there is a probability that you can find an electron in this, right? You cannot, which is called because of the Heisenberg uncertainty principle. If you locate the position, then the velocity information is lost. If you find the velocity, the location information is lost. That is what Heisenberg uncertainty principle says. And that is why there is always an uncertainty given by the Heisenberg's H cross. Okay, the H cross gives you the uncertainty of measuring everything. So this beautiful thing did not convince Einstein. Einstein always went on telling, there's a famous sentence by Einstein. He said that, look, God doesn't play dice. Means nothing can be probabilistic. There is always a cause and effect. So there is a famous paper called as the EPR paradox, which is probably cited some 1.5 million times. Okay, amazingly cited paper, probably the highest cited paper in the whole world. Okay, because he raised this question of, is it possible without cause and effect? Is it a probabilistic? So he said, God doesn't play dice. And he wrote this letter to Niels Bohr, who replied to him, Albert Einstein, you don't have to tell God how he has to play, whether he plays dice or he plays anything. You have to only find out how he plays, right? You cannot tell that because nature behaves in a certain way. Now the question is for us to understand how the nature behaves. So this is what it is. Ultimately, we know we led this to the lot of elements. Mendeleev amazingly put everything together, the periodic table. We know that we celebrated about 2 years ago the fantastic 150-year of the periodic table, beautiful achievement which gave a lot of place to chemistry. Okay, beautiful. Then, of course, once we knew atoms, now the question is, but one single atom doesn't mean anything. They have to bond together to form a compound or to form any material. Anything we know is basically a lot of atoms put together, millions and millions of atoms put together. So how do they bond with each other? How do atoms bond each other? Which atom will bind to which atom? And this is the question Linus Pauling asked. Linus Pauling asked this question and wrote this beautiful book called as The Chemical Bond. The chemical bond is extremely important to understand. Then he could explain from that how small molecules, not only small molecules, how large molecules can form, how biological molecules can form, how proteins can form, how so many beautiful things can form. And then we had Francis Crick, James Watson, and of course Rosalind Franklin and Wilson. They were together. They discovered what is called as the DNA. DNA is an amazing double helix model. You know that double helix, okay, which has beautiful properties and which defines everything we do in life. And then there are genes inside these DNAs which determine every property of ours. So this beautiful discovery and the combination of Linus Pauling led to some wonderful understanding about biology. It transformed the way biology. It's very interesting, by the way, to tell you that C.V. Raman said that physics is the only subject. All other subjects are applications of physics. In fact, he went on to close down the chemistry department in IIT Kanpur. He said that chemistry cannot be a department. It's not a different subject. It is only application of physics. You cannot tell that it is a fundamental science. So anyway, I'm sure the chemists will not like this statement, but that was true with Simon Rao. Because ultimately, chemistry cannot explain everything. To understand everything which happens in chemistry, you need to come to physics, right? And ultimately, the language of physics is mathematics. So combination of physics and mathematics explains everything. But of course, these fields are also equally important. The biology, the chemistry, all sorts of things become very important because of this growth of this knowledge, right? So now we also have time to remember G.N. Ramachandran from Indians of Science, Bangalore, who also found out what is called as the triple helix model for a triple helix model. So, of course, he was also one of the top contenders for the Nobel Prize at that time. He found out like this. Now, using this, we are able to map the human genome. We are able to understand so many beautiful things about biology. So, this field has also become very, very beautiful. Now, Ingenhouse asked this question, why are the leaves green? Okay, he wanted to know, why are the leaves green? What is the job they are doing? Now, we all know, then he found out what is called as the photosynthesis. Right? So photosynthesis, he understood how photosynthesis works. It's a very complex process. As you can see here, it's a very complex process, but it's also a very inefficient process. You know that leaves do part of photosynthesis, most of the light they absorb and do it, but the amount of output they give is very, very little. It is a very efficient, only a few percent efficiency, very bad efficiency. So now scientists are trying to see, can we do artificial photosynthesis? Can we do a photosynthesis which is more efficient than what the plants can do? Can we plan that by watching the plant, by copying the plant, and then doing something very beautiful? So these are some beautiful experiments which are being done now to find out how to split water by using sunlight. If we can split water and separate hydrogen and oxygen and get hydrogen, we can get one of the greatest source of energy. So now the question is, how do you do water splitting? Different techniques are there, different methods are there. Even Professor C.N.R. Rao is involved. He has also contributed to this field enormously to do this. And ultimately, we know that already there are cars which run on water. Of course, they are not efficient, it cannot be used, etc. But experimentally, it can be done. But once all of you become great scientists, you can solve this problem, and then all the cars will roam around only with water. It's not very far away, my friends. These are some beautiful things which are possible in the future. Again, keep asking this question, why, how, and what for everything you see. That's very important. And then, of course, the questions came up. Why are materials conductors interrelated in semiconductors? Again, I'll not go into this because I'm running out of time. So you can find out some beautiful things in this. And then you have semiconductors. You invented, Michael Faraday was the first one to see. Michael Faraday, one of the greatest scientists. Then how this LEDs have come out of it, solar cells have come out of it. Again, let me jump these slides. Okay. So now you see, friends, I'll jump all this. Okay. So there are beautiful things which have come out of semiconductor, and there is one great achievement which is called as the triple heterojunction. Okay, the heterostructures in semiconductors, which got a Nobel Prize here because, especially from the work of Alfa Rao and Kromer. They did some beautiful work. Of course, Kilby was also given because Kilby invented some form of a semiconductor, but ultimately they got the Nobel Prize for what is called as the double heterostructure. The double heterostructure is the basis of most of the beautiful semiconductor devices, especially the optoelectronic devices, because you can enhance it. Again, I don't have time to do this, but they went on asking, how do I trap the electrons in a short way? How do I make the recombination of electron and holes efficiently? So these simple questions went on making them idea. In this work, the heterostructure work, it's very simple. They just learned how to bend the bands. If you know how to bend the bands, you can stop the electrons from going efficiently. If you can bend the band like this, you can make the electrons go efficiently. Like that, some simple how to do this helped us in creating a revolution in semiconductors. You know that semiconductors have revolutionized the whole world, and one of the greatest contributions was from from Cromer and Alpha. Okay, so now friends, now I'll come to something else. This is the picture of Albert Hibbs. He was a mathematician, a very close friend of Richard Feynman, and they were discussing. And they were just chatting over a glass of beer when they found out, when Albert Hibbs asked Feynman just for fun, he said, hey, it's very, in those days, I mean, maybe 50, 60 years ago, he asked, it's very painful that the surgeon has to cut the body of a body to do some surgery inside. So he said, can't we make some tiny surgeons, okay, and tell them what to do and send them with a knife so that they will go there, they will reach the place which they have to cut. They'll open the knife and cut it. Okay, it was just for fun. This was 50, 60 years ago. It was just a fun. But Richard Feynman took it very seriously. He started thinking about, is it possible to do that? Then he said, that can we make tiny motors? Can we make a motor which is less than 1 micron in size? Can we make a motor which is half a micron in size? So this is how he discovered. And that was the birth of nanotechnology and nanoscience. And this is, again, some 3 great peoples in nanoscience. Richard Feynman, Taniguchi called it as nano, who gave the name nano, and Drexler was a technologist who made a lot of patents to understand how to utilize this nano. But the concept came from Richard Feynman, one of the greatest physicists the world has ever seen, who said a famous sentence that there's a plenty of room in the bottom, and that is the basis of nanotechnology. So again, many people are there. Harry Kroto, who made the C60 molecule. So then Subio Ijima just thought, how can I make this ball into a tube? How can I stretch it into a tube? And Andre Geim said that, how can I make layers of this? There were layers of this, but he found out there's some very interesting properties of layers. So in 2014, Andre Geim got the Nobel Prize for finding out graphene. And then we have Gerd Bennig with Richard Rohrer, able to understand what is called as a STM, and was able to see single atoms, beautiful pictures. I don't have time to explain all this. These are some quantum corals, iron atoms put on nickel surfaces. You can see some beautiful pictures at the most microscopic level. These called as scanning tunneling microscopes are the ones which could pick up individual atoms and put them wherever you want. Individual atoms you can pick up. Such a beautiful achievement they have done by inventing the scanning tunneling microscope. Also, again, as I said, our own C.N.R. Rao has made hundreds of materials, of nanomaterials. People who thought that we cannot make a nanomaterial out of this, he was able to make beautiful hundreds of materials and contributed to the knowledge of the world in nanoscience. Of course, how it happens is a big story. Again, I'll cut this short, but these are some questions which helped understand that. And look at this. This is a question. Narendra Singh Kapani. He was an Indian who was working in the college, University College London. At that time, he said that light was going always in a straight line. We say that rectilinear propagation of light goes in a straight line. He says, how can I bend light? So he asked this question, how can I bend light? And ultimately, he found out what are called as optic fibers. He invented what is called as optic fibers, and Narendra Singh Kapani is called as the man who bent light. He was able to bend light, and that is a great achievement of Narendra Kapani. And now we know it has revolutionized communication. All this what we are doing on the WebEx, on this one, the internet, our mobile phones, everything is working on 2 things. One is the semiconductor heterostructures, which I talked about by Alpha Rao, and then again by fiber optics by Kapani. So these are the great contributions which have made communication so dominant, so possible. Even in this corona, we were able to enjoy fantastic jokes by the WhatsApp, right? Because thanks to this optic fiber by Kapani and other people. Of course, there are other contributions, but he was the first one to find out optic fibers, the concept of optic fiber. Then let me tell you something very interesting is happening in this world. Now, last year, but 2018 July, there was a paper written by Cordio and Wood, the picture I show here. And the title of the paper says, The Death of Death by the year 2045. So they say that we can conquer death. After 2045, nobody will die a natural death. They are not telling what happens with coronavirus comes or somebody murders or accidents or anything, but natural death can be conquered. Because now we understand what is aging and what is death. So we know so many beautiful things about aging and death that we know how to control death, how to control aging. So now I have become old, but you people, young people, may remain young forever. You may not die at all. You may celebrate your 200th birthday, maybe 300th birthday, and marry when you are 500 years old. Okay, think about it. Maybe children, maybe start thinking when you are 800 years old, you can start thinking about children. You can do some beautiful things in the possibility because of this death. So I'm giving a lot of terms. I know something will interest you. And when something interests you, go and Google it. Google it and see death of death. Just Google the word death of death. You will see their work. And if you like, if you enjoy it, go and understand it. Once you understand it, go on asking these simple questions. Why, how, what? Okay, you can get beautiful information on the internet. Internet is the universal guru. Okay, Google Amma is the greatest knowledgeable person. Okay, you can ask her, she will tell you all the answers. She will whenever I ask a question to my wife, she gives me 1,000 answers. Google Amma will give you 1 billion answers. Okay, so many opportunities are there. So many beautiful things are possible now, which we could not get as students. So please use it. Okay, so friends, let me come to one of my last slides, which says, really, I'll tell you, to become a good student of science, first thing you need to do is you have to marvel nature. Oh my God, this nature is so beautiful. I am so beautiful. Everything is so beautiful, wonderful. This nature works so complex, so beautiful. Okay, you have to marvel the nature. Then you have to respect knowledge. You have to give respect to people with knowledge. You cannot give respect to the people with a lot of money or a lot of power or a lot of everything. A minister, they don't give respect to them. Give respect to the people who have knowledge. Okay, once you do that, then you know that, then you will find that you can. Another thing to become a scientist is emotionally appreciate the size of an atom and the size of the universe. As I showed you, so big, so small. If you tell it is big, it is small, you are not emotionally understood. If you say so big, so small, emotionally, if you feel the size of an atom, you will become a scientist. Now, so the idea is you have to develop the ability to ask questions. That is normal. Every human being asks questions, but you have to pursue it. You have to go behind that question for many, many years. Then you will understand it. And once you understand it, and then you will start thinking how to contribute to this world. You will find something new which the world did not know, and that is how you become a scientist. Right? It's just the simple questions which are there. All these people I showed you, they asked these small questions, simple questions, and got the big answers for the world. I'm sure you all can have the capability of getting this knowledge, asking these small questions, pursuing it up to the end. Go on thinking about it. Every question is a right question. There is no wrong question. There may be answers. You get the answer. Somebody has already done it. Then ask the next question, next question, next question. You will reach the region of interface. Like a scientist. Scientist works between the interface between knowledge and ignorance. So he is at the interface between knowledge and ignorance. That is why scientist doesn't know what he is doing. If a scientist tells me, if you ask a scientist, what are you doing? And if he tells what he is doing, then he is not a scientist. He is a technologist or an engineer. If he says, I don't know what I'm doing, then he is a scientist, right? Because he is working in the interface of ignorance. So as you grow, okay, the balloon here, as you can see here, the knowledge balloon keeps growing. But the problem is the area of contact with the ignorance around it also becomes larger and larger. So ignorance will always remain. And that is why knowledge will always grow. There is a lot of there's no end for knowledge. It is there, it's there, it's there. And we all have to enjoy accumulating this knowledge, learning the knowledge, and also contributing to the knowledge in our own ability. So how you have to do this is you have to stretch your body, then it becomes a dance. We all have a body, but some people know how to stretch it, how to control it, how to move it, and they become a dance. Or it also become a sport. Today IPL is starting. Okay, you will see beautiful games by Dhoni and Rohit Sharma today, right? So they have done it because they were able to control their body. They stretch the ability of the body to make, and that's how they have become great sportsmen. So if you stretch your voice, we all have a voice, but if you stretch your voice, okay, you can make music. Beautiful music comes out of voice and noise. Okay, otherwise we make a lot of noise, right? So you stretch your curiosity, then you make science. So the secret behind becoming a scientist is to become curious and curious. Like Alice in Wonderland said, curiouser and curiouser. And that is the key word for becoming a scientist. Now, if you stretch your imagination, then you become a philosopher. So ultimately, everything becomes a philosophy. And that is why every degree, okay, you do a commerce, physics, chemistry, everywhere, ultimately PhD is called as Doctor of Philosophy. And that we need to know. It's not given as Doctor of Physics, Doctor of Chemistry. It's all Doctor of Philosophy, because all knowledge merges into this, what is called as philosophy. And that is the beauty of this world. So we want you to become normal scientists, normal students of science, to ultimately become those great philosophers. And that's what these people are. All the scientists are shown, they are not scientists anymore. They are philosophers. Okay? They have found out the philosophy of life, why life lives, how does it work, etc., etc. So now I think if I stretch my lecture further, it will become violence. So let me stop here. Okay. But last slide, see, we have two great scientists in India. One, on the left side, okay, is C.V. Rao, okay, the greatest scientist. And right side is C.N.R. Rao, the living scientist, the living legend now, the C.N.R. Now the question is, both of them wanted India to become very strong in science. So, okay, they wanted to put somebody else's photograph here in between. So whose photograph it is? My young friends, it should be your photograph. Each of you should try to put your photograph among these two great scientists in India. So that's what it is when you can shout at the end, I know, Eureka, Eureka, right? That's what it is. Thank you all. And I thank the internet for all the beautiful pictures and the knowledge and so many things I've learned. And also for all of you for having the patience to listen to me for so long. If I bored you to death, you can take revenge some other time on me. Thank you very much. Yeah. Okay.
Thank you, sir. Sir, can we take some questions?
Yeah, please.
Okay, sir. Okay, sir. One of the participant is asking.
Just 1 minute.
Is it okay? Okay, sir.
Give me 1 second.
Sure, sir.
Find out.
Okay, sir. Okay, sir. No problem.
Okay, fine. I'm ready now. Yeah.
Okay, sir. How papers are published? I mean, how the work of the scientist is recognized? This is the question from one of the participants.
Don't worry about recognition. Let me tell you, recognition is only a consequence. Recognition, the prize, the money, the awards are nonsense. Okay, they are not important at all. They will come automatically. Okay, you don't have to go after them. They should come after you. Okay, you should develop an ability. You don't do something because you want to get something. Okay? You do it because you want to enjoy your life, enjoy your curiosity, enjoy your question. So go after your question. You go after your question, go after knowledge, go after it. Just forget about what the world says. Let me tell you, let me assure you, all these prizes, money, everything, fame, everything will follow you. Okay, so don't think about awards. If you start thinking about awards, you will never become a scientist. You will become a stupid, ordinary fellow like you and me, like me. Right? You can think of something even bigger than that. Yeah. Okay.
Thank you, sir. One more question.
Yeah.
How to develop scientific temper in general public, those who don't have the scientific background?
Yeah. Very good question and a very important question, because I think KSTA and everybody is doing these kind of activities. A lot of activities are going on in this to build the scientific temper. What is scientific temper doesn't mean science. Please let us understand, teaching science is not scientific temper. Scientific temper means thinking logically. Okay, so if you can think logically, that is scientific temper. The idea of science is that it is logical. See, if I don't believe, I don't have faith in anything in science. I don't believe that it's something God exists or anything of that sort. It's not necessary for us to think like that, right? If the question is, for me, everything has to be explained. If I don't know, Newton came out with his laws, but ultimately Einstein showed that it was wrong. Newton's laws was wrong. And then Einstein's theory came, then ultimately quantum mechanics showed that Einstein was wrong in certain places. So like that, the world grows, the knowledge grows, etc., etc. So the idea why we call it a science is because it is a logical path. Okay, we take a logical path to go from one place to the other. So the idea of scientific temper means tell people that, look, do everything logically. Let it make sense. Let it make meaning to you. Okay, that is what is scientific temper. It is not about knowing science. Science is a good example of showing scientific temper. That's all. But scientific temper does not mean science. So please tell people, don't blindly follow anything. Right? We tell them superstitions. Don't do superstitions. They have no logic. They have no sense. Okay, we don't know. Of course, there are many things which science also doesn't know, but science accepts very nicely and tells, "I don't know." Okay, we know only this much. We don't know beyond that. Let's find out. Okay, we'll wait for Akshay Bhatt to become a scientist. Okay, we want him to find out. Okay, how to go. So we'll find it out. But let us not believe something because we don't see it. That is scientific temper. I think this is what we have to tell people. Look, if it convinces you that it is logical, please do it. Otherwise, don't do it. This is how we have to spread the sense of logical. And then that is why we said superstitions are all illogical. All superstitions are illogical. So tell people, look, stop the superstitions. Follow the concepts of science. That's the best way to understand the world.
Okay. Thank you, sir. Sir, one more question. Can I take one more question?
Please. You can take as many as you want.
Okay. What if aliens are time travelers from future? What's your answer, sir? One of the participants is asking.
Very good. Yeah. So, see, you should not only you are also an alien for somebody else, right? They are also thinking that you as an alien. So you're also an alien only. Don't think that aliens means they look differently. You're also an alien for somebody else. So, see, there is a possibility. There are some beautiful work which has been done, which they've calculated the probability of finding aliens. Okay, that there may be other worlds which are also very possible, because with so many stars, so many bodies, there may be another one like Earth, or maybe something better than Earth, something different from Earth. So this is the probability is there, okay, that they exist, but we have not seen anything yet. It's only imagination. All the stories we hear here and there are all lies. Okay, there is nothing which has proved that aliens exist at this particular time. Okay, but maybe one day we'll come up with aliens who may be smarter than us or stupid than us. We don't know what they are. So right now, let us not believe that they exist, but they may be existing. There is a calculation. There are so many things which are possible. So it is one of the possibilities that there may be other worlds where people live. Right now, let's hunt for it. Let's look for it. But let us not believe the stories which people tell. Yeah.
Okay.
Yeah.
Thank you, sir. Thank you, sir.
Yeah.
What is the importance of interdisciplinary research?
Yes. I mean, of course, as I said, everything in this world is interdisciplinary. Okay, I mean, nothing is specific. Now, the silos of saying that I'm a physicist, I'm a chemist, I'm a biologist, etc., doesn't exist anymore, right? And now, like especially with nanoscience coming, okay, every physicist has to know biology, biologist has to know physics, physics has to interact with a mathematician. I mean, everything is coming. So, interdisciplinary research is important to understand anything, because the simpler things have been understood. Otherwise, it will be like the 5 blind men who were looking at the elephant. You remember the 5 blind men? He said it's like a rope, it's like a pillar, it's like a wall, it's like that, this, everything. But ultimately, if it is multidisciplinary approach, then you will understand it's actually an elephant. It is not a wall, it's the rope. So that is what multidisciplinary is all about. But let me tell you, nowadays you need specialization. You cannot become jack of all, right? You need specialization in one thing. So the idea of becoming multidisciplinary is not you knowing everything. Okay, you should not try to know everything, but have friends who know other things. So develop a group, working in a team is very, very important. Your specialization, you will tell, their specialization, you will tell. Like that, all of you will think together to come with some multidisciplinary approaches to the problem. But if you remain only multidisciplinary, our knowledge will remain very superficial. It will not go to the depth. So working in teams is a very important thing for science. So science doesn't mean that you can work in silos, right? You have to work in teams, and that is what the future is. Now, for example, the new fields, you need very sophisticated instruments. You cannot work and say, I want everything, all the instruments. It is impossible to collect. So you need to know how to collaborate with people, how to interact with people, not only from your college or your school, maybe some other college, maybe abroad. Okay, with all this internet and these facilities, you can make links with anybody anywhere in the world. So you can send some sample, they will study, send you something, etc. They will give you some ideas, you give some ideas. But more important, my friends, is your brain. Utilize your brain. Science is not about working. It is not about working hard. It is about utilizing your brain. If you utilize your brain very efficiently, you have to work very little. The smart people, instead of working hard, you have to work smart. Okay, once you work smart, the amount of effort you have to put becomes less, and the amount of sense you make becomes more. That's why I keep telling, keep asking these questions, these simple questions on anything you do, anything you see. Why, what, how? Initially, they may be very, very silly questions. They may be very ordinary questions. But slowly, as your knowledge grows, they'll become very, very complex. Within a year or two, you will find out that you are asking some of the deepest questions the world wants to know. right? In a couple of years, you will become somebody who is asking some of the most fantastic questions which people don't know. In the whole world, they don't know. And you may be one who can find an answer to that. And once you find an answer, you become. So multidisciplinary approach is necessary, but perfecting your field of expertise is also equally important. Yeah. Okay.
Sir. Thank you, sir. One more question, sir. How the peer review is done while publishing articles?
Again, I said, yeah. See, that is my problem about research. When people think it is research, because the government has put some rules, you have to produce so much people's paper, you have to get a PhD, etc., etc. So people have started doing all dirty things to publish research papers and get a PhD, right? But it has lost the value of the real value of science. Okay, so that is the biggest problem. Let us not worry how to publish papers. Just start reading papers. Okay, you will understand how to write a paper. I keep telling, if to all my research students, I tell this, like, an apple a day keeps the doctor away, right? We all know this. So, but if you want to become a scientist, you have to read one research paper in the morning. Every day you read one research paper, whether you understood or not. Every day you read one research paper, you will know how to do research, you will know how to write a research paper, you will know how it will be peer reviewed, you will know everything about it. So it will automatically follow. Please don't do for the end. Okay, the means is more important than the end. And if your means are good, your end will be great. There is no doubt about that. But please work for the means. Okay, you will become. So don't think that. I keep telling, exam is not important. Exam is not at all important. Even if you fail this year, it is okay. Next year you can pass. Don't worry about those things. But how much you have enjoyed accumulating knowledge, how much you have enjoyed understanding something will pay you in the long run. Okay, 1 or 2 years in your life doesn't matter at all. Okay, ask me or ask Ramesh or anybody. 1 or 2 years doesn't matter in our life at all, right? If we had done better, if we have understood better, we will have a much better life. Again, better life means I'm not talking about your car and bungalow and everything. That will all come. Let them all come. But that, more importantly, you will be satisfied. You will be happy. People will recognize you and say, "My God, this fellow is different from others." Right? And that appreciation is what we are looking for. And more than the appreciation from others, appreciate yourself. I am alive, I am capable. I have 80 billion neurons in my brain. Same number as Einstein also had 80 billion neurons. There's no difference between Einstein and me. Okay, only he used his neurons in a certain direction. I allowed my neurons to do in different directions. That is why I could not become an Einstein. I became an ordinary Shiva Prasad. So now, most of you should think now how to utilize your brain in a very systematic way, use those neurons and make the connections in a certain direction so that you can be satisfied that you contributed something to this world. You understood the issues in this world and you also contributed something to the world. That should be your aim. Yeah. Rest all will follow. All your papers, see, research is not about PhD or not about research papers or anything of that sort. They are only consequences. They are side business. As I said, even awards, your everything, they come and go. Okay, sometimes they come, sometimes they go, etc. But what is important is your curiosity, your questions, the curiosity, and how you follow your curiosity. It is your own curiosity. You own it. Okay, my curiosity will be different from Umesh's curiosity. Okay, it will be different from Abhishek's curiosity. He has a different curiosity. So you have to own it. You have to own your curiosity and then fight to satisfy that curiosity. And that is real research. And that, when you do it in a systematic manner, it becomes scientific research. When you don't do it in a systematic manner, it becomes, useless knowledge. But when you do it systematically in a certain methodology, which is well defined, well understood, then it becomes research. And that's what we have to plan. Not for about review, paper, leave all this. It will automatically happen. I'm sure it will happen on its own. Yeah.
Okay. Thank you, sir. Sir, one more question.
Yeah.
There is POCE and POBE in JNCASR.
Yeah.
Why not for physics?
Good question. Actually, JNCSR was dominated by chemists for a long time. Only now some physicists have come because it's more of material science. Okay, it is not. We don't have physics chemistry department. It's a multidisciplinary field called as material science. Yes, POPE is also necessary. POPE is necessary in the future. Sometime it will happen, but probably we need a little bit more critical mass of people. But the kind of POCE program, the POCE program, there are also a lot of physics. I also participate in that. So we all physicists also participate in it. The name is chemistry, but it's actually material science, which involves both physics, chemistry, materials, everything together. Yeah, even biology, but to some extent. Yeah.
That's it, sir.
Yeah.
Thank you, sir. That's it. There is no question. There is no other question, sir.
Great. Yeah.
Uh, Ramesh sir, can you please wind up the session?
Sir, once again, a very exciting session by you, sir. In
Thank
fact, at 55 years, I also am very excited to become a scientist. I think
Wonderful. Okay, I should tell you a story then. Okay, there is a story of a scientist called Ivar Gever. Okay, Ivar Gever, when he was 40, he did not go to school, he did not do anything. Okay, he was a vagabond. Okay, and at 46 years, he started doing science, learning science. Okay, when he was 46, he started his career in science. He started understanding something. There's a very beautiful story. Somebody should read it. And ultimately, at the age of 74, he got a Nobel Prize in physics in semiconductors. Suddenly, so we are also hoping that Ramesh ji will get a Nobel Prize soon. We are waiting for that. Yeah, very nice. So yeah, I mean, age is not a barrier for all of us. You have to start somewhere. Whenever you start, you are young. Whether you are 20 or you're 50 or 60 or anything, you have to start, and that is when you are young, right? So Ramesh ji is very young, though he does not have some hair on his head, but still he's very young, I think. Yeah. Okay.
very much, sir. Certainly, I will try. Many youngsters are there. They are very excited by your talk. I'm sure many of them will pursue science, pursue research, and come up with very good outcomes. Sir, really, I would like to emulate you in giving talks like you. It was very exciting with lot of anecdotes, stories. Really, we are very thankful to you. And on behalf of KSTA, Gravity Institute, we all thank you immensely for your time and exciting talk. We will be inviting you for many more talks like this. In fact, in Tumkur, I've heard sir started at 4, and when he left, it was more than 7:30 in the evening. Many students were seated in their respective seats to hear sir. Such a wonderful speaker you are. I only wish that I had a wonderful teacher like you. I would have continued in science field. Such a CEO. Thank you very much, sir. I would also take this opportunity to thank Mr. Abhishek and my colleague Mr. Umesh for arranging this wonderful talk. Thank you very much, all the participants, for your patience. Thank you, one and all. Thank you very much.
Thank you. Thank you.
Thank you, sir. Thank you very
I
much, sir.
also, I also thank Abhishek and
Thank you, sir.
Ramesh ji and everybody for giving this opportunity. Yeah.
Thank you, sir. Thank you very much, sir. Thank you, sir.
Thank you.